In this video, we're going to learn about the concepts of measurements and significant figures. Measurements are physical quantities used to describe matter and its behaviors. The earliest units used for measurements were based on the dimensions of the human body. For example, Egyptians utilized the cubit as a unit of measurement for length. They would select a leader and they would measure that person's arm from the elbow to the tip of the middle finger, and that will be the unit specifically for the cubit. What this created was a variation in the actual unit of measurement, because since it was dependent on the person's length of the arm, as I just described, the cubit could vary anywhere from 18 to 21 inches. As you can imagine, scientists needed to develop a more standardized way to look at units of measurement. And that's why they created the metric system for measurements. Later, a modification of this metric system was created, and they developed the SI unit for measurements. When it comes to units of measurements, as I just described, by now we have the metric unit system, the SI unit system, and even the English unit system. In table 1.3, what is illustrating is just commonly used units in multiple systems of measurements. We can observe the different quantities, and this is just representing a short list. And these quantities are going to be different ways in which we can measure matter and its behavior. You can observe that here we have, for example, length, volume, mass, temperature, time, and energy. The important thing about table 1.3 is that you familiarize yourself with the terms for the unit of measurements that are represented here and how it relates to the quantity that it describes. Additionally, you should know the letter that is in the parentheses, which is the abbreviation for that unit of measurement. The reason why you need to be familiar with this is because we're going to use this throughout this chapter and later in the semester. Now we are going to focus our efforts to understand how do we write measurements. When it comes to a measurement, measurements are composed of two parts. Those two parts are numbers, meaning digits, and we have a defining unit. And it's going to be one of those units that we were talking about in table 1.3. Now, in a measured number, those digits that we have in the measurement are known as significant figures. And the significant figures are going to be the digits that carry meaning, contributing to the measurement resolution. The resolution is going to be based on the markings on the instrument that we utilize. So how do we write a measured number? As I just mentioned, we need numbers and we need a unit. When it comes to the numbers themselves, we need two types of digits. We need known digits, which these are going to be determined by the marked lines on the instrument that we're utilizing. And in addition, we need to have an estimated value. This estimated value is going to be an estimate for the numbers that we think are there based of the estimate in between the marked lines. Lastly, we need a unit of measurement. So to illustrate an example of how we write a measure number, let's focus on the image that we have on the right side of the slide. And I'm going to zoom in to look at this more closely. So in figure 1.21, we have specifically two different squares. In these squares, as you can see on letter A, there's a ruler that has markings. And on ruler B, we have the object and a ruler, but the ruler has more markings. So when I write the measurement based on my instrument, either ruler A or ruler B, the difference mainly is going to be on the known digits that are present due to the marked lines that are in the instrument. So if I measure my object with ruler A, I'm going to do a line so I can have a better sense of the estimated digit that I'm going to write. Let me redraw that line. So looking at that square, I know that when I examine its length with that first ruler, it will extend to at least one, but not quite two. So that means that if I write the measured number used on the based on the markings that that ruler has, the known digit will be 1. My estimated digit will be the number that I estimate between 1 and 2. So I'm going to estimate 0.8. The unit of measurement used here, centimeters. The abbreviation for centimeters is cm. As I observed the same object, but with a ruler that has more markings, then since I have more markings, I know that then my known digits are going to be more when I write them down. So what this means is that if I do the same exercise from the edge, I actually draw a line onto the ruler. I'm going to zoom in a little bit more so we can look at this closer. I can observe that in this instrument, for example, my known digits are going to be 1.8 because when I look closely, I have the marking for 1, I have the marking for 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. But my instrument, based on my line, it is in between 1.8 and 1.9. So my estimated digit is going to be a value that represents that is closer to 1.9. So I can determine that the digit of 9 after the 0.8 is going to be my estimated digit. I always need a unit. So I'm going to write cm because that's the unit of measurement when it comes to this ruler. What this is illustrating is that if your instrument, just like we see in the ruler on part B, has more markings, that means that you can read more digits in it, and then the resulting measurement is going to have more significant figures compared to a ruler that has less markings. In the laboratory, other than measuring length, at times we are going to be measuring volume. And this is another instance in which we have to pay attention to the markings that we have. I want to introduce to you how to correctly measure volume when it comes to the laboratory. One of the things about measuring volume is that at times, liquid substances, depending on the interaction that they have with the material of the instrument that we use for measuring volume, is going to create what is called a meniscus. And the meniscus is simply a curvature that forms because of the interaction of the substance with the material of your measuring device. In this case, it could be a graduated cylinder, for example. The meniscus in this case is a curvature that is pointing down. When we're reading the volume of a liquid in such instrument, understand that what we have to do is look at the curvature by putting it at eye level, and from there doing our reading. I'm going to zoom in into the image on the left side to illustrate how do we read the volume, specifically when we have such meniscus. By examining the known digits, we can observe that in this instrument, we have values from 30 to 40, and we have some marked lines. And these marked lines are going to represent 1 milliliter. Because if I count, this line represents 30, this is 31, 32, 33, 34, 35, 36, 37, all the way to 40. So if I'm trying to determine what is the volume of this liquid utilizing this instrument, I can determine that this, based on my known digits, is at least 36 milliliters, and then I have to write an estimate. The estimate digit or the estimated digit is always needed. I'm going to estimate that this is going to be zero point 0.7. So the correct value for the volume of this liquid in this instrument will be 36.7 milliliters. I want to do just one more practice problem. Now I'm going to zoom in onto the image that I have on the right. The first thing that I have to see is what are my marked lines actually representing? When I look closely and I examine this instrument, I can see that my numbers go from the digit 6 all the way to 8. So what this implies is that these lines are going to be representing zero point 0.2 milliliters. So I go from 6 to 6.2, 6.4, 6.6, 6.8, 7, all the way to 8. So when I look at specifically the volume of this liquid in this instrument, and I mark the bottom of the meniscus, which would be around here, I'm going to be estimating, for example, that this is going to be from the marked lines at least 6.6 milliliters. And then my estimated digit, if I look close to this, is going to be just a little bit above that 6.6 line. So I'm going to estimate 0.02. So the correct volume, at least based on the measurement that I can observe, is going to be 6.62 milliliters. But if you see this as 6.61, that is also okay. Remember that when it comes to this is just an estimate and it depends on the observer. If we have collected measurements, there's actual rules to determine how many significant figures are present in that measurement. The 4 rules that are utilized to determine which digits in my measurement are going to carry meaning are outlined on the left side of the slide. Let's go through each of them. Rule number 1, non-zero digits. It is known that all non-zero numbers are significant. That means that all the digits that are not zero are going to carry meaning. We can observe in the image that we have on the right side of the slide in figure 1.22, where our non-zero digits are located. Next, leading zeros. Zeros not preceded by a non-zero number are not significant. These numbers or these zeros are known as placeholders. And in measurements that are less than 1, that's where they are going to be present. So we can see in the example that we have on the right where our leading zeros are. Next, we have zeros that are going to be buried. Buried zeros are going to be zeros located between non-zero digits, and those are going to carry meaning. We can see that in the measurement that we have a buried zero right here. Lastly, trailing zeros. Zeros that are located at the end of a number are going to be significant figures if a decimal point is present. So those are the two parameters for trailing zeros. They need to be located at the end of a number, meaning a non-zero digit, and a decimal point need to be present in your measurement. So for example, this is a trailing zero because we can see that it is after the first non-zero digit and there is a decimal place. Let's actually do some practice to determine the number of significant figures in given measurements. When we look at example A, 24.6 degrees Celsius, which is a measurement for temperature, we can observe that all the digits here are non-zero digits. So that means that we have 3 significant figures. The shorthand that I utilize for significant figures is SF. When we look at letter B, we have the measurement 0.036 grams, which is a measurement for mass. When it comes to this measurement has 2 significant figures because the zeros here are going to be placeholders. Next, we have the measurement 15.0 milliliters. When it comes to this measurement for volume, what we have is a trailing zero that is present after a decimal point and after a non-zero digit. So that means that in this measurement, we have 3 significant figures.